Hello and welcome. Mr. Martino here for your favorite teacher. In this lesson, we're going to look at the perimeter of circles, including circles as part of a compound shape. The perimeter of shapes has been looked at in a previous lesson, so we will assume your general understanding is already known. Circles provide a unique set of challenges and problems that are not associated with shapes that are made up entirely of straight lines. However, they are an integral part of geometry, and the origin of investigating them goes back almost 3,000 years. In this lesson, we'll look at the perimeter of a circle called the circumference, as well as how it's calculated and applications of that knowledge. The main parts of a circle are called the circumference, the diameter, and the radius. The diameter is a straight line drawn from one point of the circumference through the middle of the circle to the other side. The radius of a circle is any straight line drawn from the center of a circle to any part of the circumference. The two most important equations for this lesson are the diameter is equal to 2 times the radius, or simply d equal 2r, and the circumference is equal to pi times the diameter, or c is equal to pi d. The second of these equations states that the circumference, or the perimeter of a circle, is the diameter times a constant called pi. The symbol used for pi is a Greek symbol and is universally understood when it's used. The value of pi is a number with unending decimal digits, so if we need to use it in a calculation, we approximate it to 3.142. More often than not, you will have the use of a calculator when doing these calculations, and there's a button that you can use that automatically provides the value of pi when needed. In addition, as we always use some approximation of pi, the answers we provide will always need rounding to some degree. As an example, we are told that a circle has a radius of 15 centimeters. We need to find the perimeter of the circle. Our calculation should utilize both of the equations mentioned above, so that we first find the diameter, which is twice the radius, or 30 centimeters. We then multiply this by pi, and we get the answer 94.25 to 2 decimal places. As a second example, a semicircle is drawn, and then a straight line connects the two ends. Find the perimeter of this shape if the radius of the circle was 12 centimeters. And give your answer to 1 decimal place. Since a semicircle is half a circle, we need to be careful with our calculations. The actual calculations are as follows. First, find the diameter, which is 24 centimeters. Then find the whole circumference, which is 75.4. Half the circumference, which is then 37.7. And finally, add the straight line length to this value. So our answer is 61.7 centimeters to 1 decimal place. Be careful, as many students forget to do the last part of this question and forget to add the length of the straight line to get the perimeter. For our final example, a running track is designed by adding 2 semicircles to the ends of a rectangle as shown. Certain dimensions of the track are also included, and we need to find the distance around the whole track to the nearest meter. Going around the track means we are only interested in the total perimeter. 2 straight lines of the track are both the same. So we have 100 meters plus 100 meters, which is 200 meters. At the ends, we have 2 semicircles. The diameter of each semicircle is the same as the width of the field. So the perimeter of each semicircle can be calculated as 40 times pi divided by 2, which is 62.83 meters. And since we need to include both when going all around the track, the total perimeter of the track is 200 plus 62.83 plus another 62.83, or 326 meters. Always be careful to read the question in detail and answer the question properly. I hope this has been helpful, and you can always test your understanding by taking our quizzes or trying our worksheets available on the website. This has been Mr. Martino for your favorite teacher, and thanks for watching.